Hello friends, today we are going to study about geometric relationship for open bed drive. In that, there are two main geometric terms required to designate a bed drive. They are first angle of lap and second was length of bed drive. In that, we are study about first angle of lap. Angle of lap is defined as the angle subjected at center of pulley by the portion of bed which is in contact with pulley. In second definition of angle of lap is when the two pulleys are connected by open bed drive, we can see that angle of contact of larger pulley and smaller pulley is different. In that first we are drawing the geometric relationship for bed drive. In that first, draw the center line of two pulleys. Then draw the smaller circle and larger circle. After drawing smaller circle and larger circle, then giving that circle particular naming. First smaller pulleys name was driver or driving pulley and second larger pulley's name was driven or follower pulley. In that circle D1 was diameter was smaller circle and in that larger circle diameter was D2. After drawing two circles, then join that two circles and they look like similar to that geometry. If here you can see the distance between A and B was theta and in larger pulley distance between C and D was also theta and distance between center line and A was alpha and distance between center line to the B was also alpha and in larger pulley distance between C and center line was alpha and similar to that distance between A and center line was alpha. That was geometry of open bed drive. Geometric relationship for open bed drive. If you are interested to find out theta 2, then you can adding pi plus 2 alpha, then you can get theta 2. In here theta means pi means 180 degree means half of the circle, then you can get the theta 2. Similarly the second one was angle of lap for smaller pulley theta 1 is inverse to pi minus 2 alpha. If you can interested or find out 2 theta 1, then you can minus the 2 alpha in pi, then you can get the angle of lap for smaller pulley. However, when two pulleys of different diameter are connected by means of an open bed drive, then angle of lap or contact at smaller pulley must be taken into the account. Example theta 1 because the slipping changes are more in case of smaller pulley. Angle of lap for open bed drive is taken as, you can see here the formula derived was the theta is inverse to pi minus 2 alpha in radian. In second formula was alpha is inverse to sine inverse of in bracket r2 minus r1 upon x bracket complete. And in here x means distance between center of larger pulley and smaller pulley. Second was length of open bed drive. L is inverse to pi in bracket r2 plus r1 bracket complete plus in bracket r2 minus r1 square divided by x plus 2 into x. That question was frequently asked on the question papers. First was define angle of flap in belt drive. Second, state formula to calculate length of open belt drive and cross belt drive. State the meaning of each term by drawing suitable diagram in both cases. Third, write down formula of length of belt drive for open belt drive and cross belt drive. Second was geometric relationship for cross belt drive, that is similar to the open belt drive. When two pulleys are connected by cross belt drive, then a little consideration will show that angle of contact for both pulleys are same. Let this angle be theta. Then we are drawing the geometric relationship for cross belt drive. In that first we are drawing the center line of both pulleys. After drawing the center line, drawing the two circles, one of the smaller circle and second one was larger circle. Then that circle was drawing to the two cross lines. They are similar to this. If here you can see alpha was there, and distance between two circles are center of two circle was x. From the geometric form we can see that for both pulleys, angle of lap for cross belt drive theta is inverse to pi plus 2 alpha in radian, where alpha is inverse to sine inverse in bracket r2 minus r1 by x bracket complete. In second, length of cross belt drive was L is inverse to pi in bracket r2 plus r1 bracket complete plus in bracket r2 plus r1 bracket complete divided by x plus 2x. In that topic, most of the time asked question of MSBT's question papers was first state formula to calculate length of open belt drive. State the meaning of each term by drawing suitable diagram in both cases. Then law of belting. In here we can first draw the center line of two circles and draw the diagram of similar to the open belt drive. In here the distance between that is the diameter of smaller circle d1, and that is the diameter of larger circle was d2. That is similar to the open belt drive, and they are round to the n1 speed and they are rotated the n2 speed. In here the upper side was slack side and lower side was tight side. And they are rotates that side and they are rotates of that side. Here small pulley was driving pulley and larger pulley was driven pulley. या जिओमेट्रिक मध्ये फर्स्ट एक ड्रायव्हिंग आणि एक ड्रिव्हन पुले रोटेट्स होतो. त्या रोटेट झाल्यानंतर ह्या खालच्या दोन्ही पुलेंच्या खालच्या साईडला मॅक्झिमम स्ट्रेस अप्लाय होतो आणि त्या स्ट्रेसमुळे त्या चेनमध्ये खूप स्ट्रेस तयार होतो आणि ती पुढे गेल्यावर तो स्ट्रेस कमी होतो. त्यामुळे तिथे स्लॅक साईड तयार होते आणि खालच्या टाईट साईडला टाईट साईड तयार होते. दे आर ऑल्सो सिमिलर टू द law of belting. Law of belting. The law of belting states that the center line of the belt as it approaches the pulley must lie in a plane perpendicular to the axis of the pulley or in the plane of the pulley, otherwise the belt will run out of the pulley. when two shafts are connected means of belt drive, some frictional grip between the belt drive and pulley is necessary. This can be done by the tightening the belt before the mounted on the pulley. Due to this initial tightening, the belt is subjected to the tension. It's called as the initial tension. In that topic, mostly asked question was generally the lower side is kept means tight side and upper side is kept as a slack side with the belt drives having a small driving pulley and big driving pulley. Why? Our next topic was slip of a belt. During power transmission, the driver pulley rotates which carry belt. The motion of belt and pulley is due to firm frictional grip between the belt and pulley, but sometimes frictional grip becomes insufficient, so this may causes first the forward motion of the pulley without carrying belt with it. Second one was the forward motion of belt without carrying the driven pulley with it. This is called as the slip of belt and it is expressed in a percentage. The slip of belt decrease the velocity ratio. Let's S is inverse to percentage slip of the driving pulley. S2 means percentage slip of driven pulley and belt. S is inverse to S1 plus S2 means total percentage slip between driving and driven pulley. D1 and D2 means diameter of driving and driven pulley. N1 and N2 was speed of driving and driven pulley. Is inverse to linear velocity of belt and T means thickness of belt. Velocity ratio driven in meter per second. Here you can see V is inverse to pi D1 N1 upon 60 minus pi D1 N1 by 60 into S1 upon 60. Pi D1 N1 upon 60, that is also formula was omega. V is inverse to next in bracket 1 minus S1 upon 100 bracket complete into pi into D1 into N1 by 60. Velocity of belt pausing over driving pulley per second pi D2 N2 upon 60. I will already explain pi D2 N2 upon 60 means omega also is inverse to V minus V into S2 minus S2 divided by 100 is inverse to bracket 1 minus S2 divided by 100 bracket complete V. Next one was pi D1 pi D2 N2 divided by 60 is inverse to pi D1 N1 divided by 60 bracket 1 minus S1 100 bracket complete in bracket 1 minus S2 divided by 100 bracket complete. N2 upon N1 is inverse to D1 by D2 bracket 1 minus S1 divided by 100 minus S2 divided by 100. By solving the above equation, we have got the N2 divided by N1 is inverse to D1 by D2 in bracket 1 minus S divided by 100. If thickness of the belt T is considered, then N2 divided by N1 is inverse to T D1 plus T divided by D2 plus T in bracket 1 minus S divided by 100 bracket complete. In slip of belt, power transmission takes place from the driver for the driver to belt to follower. We know that power transmission by belt drive takes place due to frictional grip existing between belt and pulley mounted on the shaft. But sometimes this frictional grip becomes insufficient. It because of the driver without carrying belt, and second one is a belt without carrying driving pulley. That is a phenomena of slip of belt. In that topic, most of the time asked question was explain the phenomena of the slip in the belt drive. Second one was to state the effects of slip on velocity ratio in the belt drive. Also state that the expression for it. Third one was define sleep in belt drive, state its effects. Fourth one was define sleep in belt drive. Then we can see the velocity ratio. In that the diagram was similar to the belt drive also. Then we can draw the first diagram and then we explain. In here R1 was the radius of the smaller pulley and R2 was the radius of the larger pulley, and the N was the speed of the driving pulley in RPM, and N2 was the speed of the driving pulley was the driver pulley. Velocity ratio or speed of ratio is defined as the ratio of velocity of driven pulley or follower to the velocity of driver pulley. Mathematically, velocity ratio or speed ratio was N2 upon N1, and we know that the peripheral velocity of the belt when passing over the driving pulley is V1 is inverse to pi d1 into n2 divided by 60, and peripheral velocity of the belt when the passing over the driving pulley is v2 is inverse to pi d2 into n2 divided by 60 in meter per second. When there is no slip, then we can write V1 is inverse to V2. Then pi d1 n1 divided by 60 is inverse to pi d2 n2 divided by 60. Then n2 upon n1 and d1 by d2. We know that 60 get cancelled, and pi that is also cancelled, and d1 was d2 was going to here and n1 was going to here, and then the formula derived by d1 n1 is inverse to d2 n2, and then d1 divided by d2 and n2 divided by n1, and we can find out the n2 divided by n1 is inverse to d1 divided by d2. When the thickness of belt T is considered, then velocity ratio is given by n2 divided by n1 is inverse to d1 plus t divided by d2 plus t. That is also the important formula. We are first study about the open belt drive, then the study about geometric relationship for open belt drive. Third one was the slip of belt, and fourth one was the velocity ratio, and last one was the law of bending. Thanks for watching.